Okay. Good morning once again. So today we are here to learn Mann-Whitney U test or Wilcoxon Ranksum test. So this is session 5, as you already know. So as I told you the other time, I said this table is very, very important. So just try and memorize it. You should be offered because they will be asking questions on it in the objectives. Okay. So when you take the parametric test, all the parametric tests had its non-parametric test. So the one sample t test that we did, its non-parametric test is what binomial. Pair t test or the the dependent samples. You get it. Its non-parametric test is Wilcoxon signed rank test or McNeman's chi-square test. And now we are about to treat the independent t test. But we are not going to treat this parametric test, that's the independent t test. Rather, we are going to treat its non-parametric test, that's the Mann-Whitney U or Wilcoxon Ranksum test. Okay, so you have to, get all of these up head. All right, so let's move on. Let me move to the right board to explain certain things. So today the topic will be Mann-Whitney. So that's the topic for the day. All right. So before I explain this particular test, I would like to give the definition for non-parametric and what parametric test. So first of all, let's treat parametric test. One may ask, what is parametric test? Now we are saying a parametric test is a test that allows us to use data which is normally distributed. In other words, it helps researchers to test for the significance of a research that uses a data which follows the normal distribution. So let me write this here. Now, one may ask, when you talk of a data which follows normal distribution, what is the meaning? So we are saying that a data is normally distributed if it follows the normal curve. And I hope we know the normal curve from quantitative method last semester. Yes, so we are saying a data follows the normal distribution if, or a data following normal distribution is the type of data which follows the normal curve. You get it? And we know the normal curve from quanti. Okay, so I would like to draw the normal curve here. Something like this. Sorry for my drawing. Yes, this one should be okay. And we are saying in this world, most of the data, these data are normally distributed. Okay, because when you take our exams grades, for instance, and look at this side, this side, the A people and the B plus and stars will be here. They are very few. Because those who will be getting A, B plus, and B, they are few. And also those who will be getting F, E, and stuff will be they are also few. They get it. These people are very few. But when you look at the larger parts, you get it. This is the average. So when you look at this part, you'll be having the D, D plus, the C plus, C here. And they are the people having the, I mean, how do I say it? Is it mode or median? Their numbers are very, very high. You get it. So the people will be having C, C plus, D, they are many. There are plenty than those who get A, B plus or B, or those who get G, F and stuff. You get it. So this is what parametric test talks about. So we are saying it's a test that allows us to use data which is normally distributed. You get it. And the data is normally distributed when it follows what the normal curve. So this is a normal curve. So if that particular data you are dealing with follows this particular normal curve, then we are saying that test is what? Parametric. Parameter. Now let me talk about the non-parametric test. You get it? Hello?
Yes, please, I get it.
Okay. We are also saying the non-parametric test is a test that does not use a data which is normally distributed. In other words, it does not follow the normal distribution. You get it?
Yes.
And we are also saying a data is not normally distributed when it follows a skewed data. You get it? So when you talk about data which is not normally distributed, that's the opposite of the parametric. We are saying that that particular data follows skewed data, but we are saying the parametric follows what? The normal curve. You get it? So the key word here is skewed. And this is how it looks like. You get it? So this one is skewed to the right, and this one is also skewed to the left. Oh, okay. So if you look at, let's use the same grids to, so we are saying that with a normal curve, those who got A, B plus, and B, and this side will be those who will be getting the F and E. You get it? And when you look at this area, the average, yeah, the D plus, D, C plus, C, and the rest. And when you look at this one, most of the students will be getting, let's say, A or something like that, or most of the students will be getting E and F. So that's what you call the skewed data. You get it? So the keyword or one way to identify whether the question we are about to tackle is parametric or non-parametric is what? The word skewed. So just take note of this. So the non-parametric test uses what? A skewed data, and the parametric test uses what? This one uses normal curve, and this one uses what? Skewed curve.
Skewed curve.
You get it?
Yes.
Okay. So let's come back to today's topic. That's a Mann-Whitney U test or Wilcoxon Ranksum test. So we are saying the people who developed this particular test, they are three. So that's why we have been using their names. So the first one is Mann, the second one is Whitney, and the last one is what? Wilcoxon. So that's why we named it after them. So it's Mann, Whitney. So in other books, they'll be writing Mann-Whitney Wilcoxon U test. So you see that you see this abbreviation. So MWW, you get it? Okay. So let's move on to this particular topic. So we are saying that the Wilcoxon Ranksum test or the Mann-Whitney U test is used for testing the equality of means in two independent or unpaired samples. So we are testing the equality of means in two independent or unpaired samples. So this one, it deals with what? Two independent samples. So this one, the populations are two. Yet, unlike the paired one, where you get one population, but you get two samples, that's before and after, that's the paired. But with the unpaired or independent, they are saying the population are two. All right. Now, let's move on to the steps in conducting hypothesis under this Mann-Whitney U test. So this one, it follows the normal one we have been doing. That's the paired or the single one. So the first one will be what? What will be the first step from what you already know?
You will formulate the null and alternate hypothesis.
Okay, so the first step is what? Formulate. So you formulate the null and what? So that's the first step in every hypothesis. You get it? So we have to know how to formulate the null and alternative. So the null is represented by HO, alternative is what? HA. Now we are saying that this Mann-Whitney or Wilcoxon Ranksum test is a non-parametric test. It uses skewed curve. We are saying that it does not use mu. You get it? So the mean is the English word, as you already know. The mu, then we present it with this sign. This sign. You get it? This Mann-Whitney U test, this one, or all the non-parametric tests, or the non-parametric tests, do not use this mu. They don't use the mu. Rather, they use what? Median. So the median will be represented by what? Capital M. You get it?
Okay.
You get where I'm coming from?
Yes, please.
If you are formulating a hypothesis, you shouldn't use HO is such that this mu is so and so greater than or equal to 0, greater than or equal to certain number or something. We don't use mu in formulating hypothesis for Mann-Whitney U test or Wilcoxon Ranksum test. Just take note that the non-parametric test, and I hope by now you get to know the test under the non-parametric. Get it? So all of the non-parametric tests do not use mu. They don't use this. Rather, they use what? Median.
Median.
Okay, so just take notes. And the good news is the words, let's say at least, at most, different from, not different from, within, not more than, improve. You get it? They all apply here. You get it? You can apply those words here. So when you hear at least in Wilcoxon Ranksum test is saying greater than or equal to, the moment you see different, then you are talking about equal sign. You get it?
Yes.
Okay, so let's move on to how we formulate the null and alternate hypothesis. So let's first of all look at the one-tailed test. And the one-tailed test, we will look at the upper and lower test. So this is the lower tail. Let's look at the lower tail first. Okay. So with this one, as I said, the two samples, as we are saying, they are unpaired or they are different. They are unpaired or they are independent. So they will take the samples, the two samples involved from two populations, not from one population. So you have M1, that is median 1, and M2, median 2. So the median from the first population and the median from the second population. You get it? So when you are writing it, it will be HO is such that M1, so the one writes superscripts. You get it? But as I move on, I'll be using a normal one because of the keyboard. But when you're writing it, just use superscripts. No, subscripts. Okay, so lower tail is greater than, the HO is greater than or equal to M2. You get it? So if that's the case, then the HO will be what? The HA, that's alternate. It will be M1 is, if the first one, the null is saying greater than or equal to, then direct opposite to be what? Less than. Yes, less than what? M2. So basically, this is how we formulate the hypothesis. One tail or Mann-Whitney U test or Wilcoxon Ranksum test. Now, we can send all of the M's, that's the M1 and M2, to the other side, and to the left side, and the right side will be 0. So you can write it in this way, or you can write it in this form as well. So HO such that M1. Let me write 1 here. But when you are writing, just use this subscripts. Greater than or equal to minus M2, then greater than or equal to 0 will come. And this one will be HA. You are bringing all the M's to one side. To M, this one it was positive. So when it crosses this sign, it will be negative. That's why we are using that. So
Okay.
M1 minus M2. So if the first one was saying greater than or equal to, the direct opposite to be less than. Okay. So when you write this or this, you get it correct. But you can use this if you don't want to get confused. You get it? You can use this. So this one, they are saying the first median is greater than or equal to what? The second median. That's what I'm trying to say. And this one is saying that the first median is less than the second median. All right, so we've looked at the lower tail test. Now let's look at the upper tail test. The upper tail test. So let's look at the upper tail under the one tail. So that one to the HO is such that HO is such that M1. I'll use the ink to write the one subscript. Is less than or equal to what? M2. And the HA will say that M1 is greater than M2. M1. M2, M2. And this is what? Less than or equal to. Or you can write it in this way. You bring all the m's to one side, and that's the left hand side, and the right hand side will be 0. So HO is such that M1 minus M2 is actually less than or equal to 0. So this one you can write it in this way, or in this way, in this way, or in this way. Do you get it? Yeah, correct. All right. So now we now look at this one tail. So let's look at the two-tailed tests. And what can you say about the two-tailed tests? What can you use to identify whether this one is two-tailed or one-tailed? There's one sign that differentiates between one-tailed and two-tailed. Is it
the equal to
sign? Good. So when you see equal to, then it's two-tailed. So that one to be HO is such that M1 as the first median is equal to what? M2. Then the HA will challenges what the HO. So HA will say that M1 is not equal to what? M2. You can write it in this way. You bring all the m's to the left hand side and send the 0 to the right hand side. So to be HO so that one will be okay. So either of them is correct. So this is how you formulate the null and alternate hypothesis. Bear in mind, we don't use mu here. We don't use this u here. We use what?
M.
As a median. So you will not hear of mean in Mann-Whitney U test. You only hear of median. Do you get it? Okay. So what will be the second step from what we already know?
So you calculate for the T critical and the T calculated.
So you see, first one you've made mistake. This one we are not dealing with T. This one is Mann-Whitney U test. Oh, I forgot to tell you, but all the same, I will treat that one after. You get it? Because here they are saying Mann-Whitney. So this one will be introduced to another table. I'll show you that table. We have U table. So we are now going to use another table which is called U table. So we started from Z, from quantity, we came to T. Now we are going to use U table. So this one, the second step is calculate the test statistics. Now the test statistic is called the U calculated or U statistic. You get it? U calculated or what? U statistic. You get it? So this one we don't have T here. We don't use T under Mann-Whitney or Wilcoxon Ranksum test. You get it? You get it? We only use what? T. And this is where the workload lies here, this particular stage or this particular step. You do a lot of workings here. Yes. Before you even choose your U. Because this one you're having two populations. So you have to calculate the U for first population and U for second population. Then you choose your U from it. And I'm going to teach you how to do that. You get it? So first of all, giving the data values from the two populations. Here is what you are going to do. You arrange the data values in ascending order. I hope you know ascending order. From lowest to highest or smallest to largest. Do you get it? So we are going to arrange these data values in ascending order from lowest to highest, irrespective of the group they belong. And you are going to rank them. And I hope you know what a rank is. The position. First, second, third, fourth, fifth, to whatever. You get it? So first of all, you arrange the data values in ascending order, that is from lowest to highest, irrespective of the group they belong to, and rank them. After ranking them, you sum up the ranks and use it to calculate the U for each group. So you take a typical example and you understand what I'm trying to say. So you let me write what I read here. So that's it. So you are going to arrange the data values in ascending order from lowest to highest, irrespective of the group they belong, and rank them. The first number or the smallest number or the lowest number will be rank number 1 for the first wherever they belong. You will take a typical example and you know what I'm trying to say. So let's move on. So this is the formula for finding U. So we're having two U's. You get it? We're having two U's. So first one, the U1 is equal to, this is the formula. So you sum up the ranks. So the first rank, the rank 1 minus N1. That's the sample size of the first population times N1 plus 1. This is divided by 2. So your U2 will be R2 minus the sample size of the second population. This one to divide by R2. The 2 affects this one. It does not affect the R2 and the R1. Take notes. Now you see that we are having two U's, U1 and U2. You get it? So the U1, when you're writing, just use the one is subscript. You get it? Don't write it big like this, subscript. Okay. So we are having two U's here, U1 and U2. But also you only need one U. Then compare it with what? The U critical. Then we decide with it. You get it? So that one too, we have the decision rule there. So what you are going to do is you are going to choose the lower U as your what? U statistic or U calculated. So lower, choose the lower U or the minimum U. U statistic or U calculated. So when you finish with this second part, you are almost done. I mean the whole question, because this is where the workload lies. You get it? The second step here. All right. So the third step is you, as usual, you calculate what?
You calculate for your critical value. That's
Critical
critical.
value. Determine your critical value. This one, as I said, we don't use T, so don't say T critical or something. It's U crit. U critical. You get it? We don't have T here, so don't be saying U critical, T critical. It's U. So as we already know, so that one too, it is U and the alpha. You match this thread. U alpha, comma N1, comma N2. I hope you know N1 and N2. Alpha is the level of significance. N1 is the population size or the sample size for the first population. Then the N2 is the sample size for the second population.
Okay.
You use U table. Use T table. Hey, U table. Use U table. And when we are solving an example, I'll show you how the U table looks like and how we determine critical value using the U table. You get it?
Yeah.
So what will be the fourth step?
So the first step is you compare to get your conclusion. So you compare whether you reject or you fail to reject.
Yeah, so you decide your we move on to the decision rule. You get it? So you decide with this. So you decide with your U calculated and U critical formulated. You get it?
Yeah.
So the decision rule is what? The decision rule for this Mann-Whitney U test is the direct opposite of the critical value approach and the parametric test.
Okay.
Is the direct opposite. So what was the rule for the critical value approach?
So the rule is when T calculated is greater than T critical, you reject HO.
Yes, so this if and that's why we are saying that if T calculated is greater than T critical, you reject HO. And I'm saying this one is the direct opposite. So how do we think the decision rule will be?
So this one you reject HO if U critical is greater than U calculated.
Yes, and always the U calculated comes first. You get it?
Yeah.
So if U calculated is less than or equal to U critical, it's the same as what you said. You get it? So if you bring U critical first, U critical will be greater than what? U calculated. All right, so that's the rule. Otherwise, you fail to reject. Okay, so this one we don't have critical value approach or p-value approach. The decision value, the decision is only one. You get it?
Yeah.
Otherwise, you fail to what? Reject. Okay. Then the last one will be what? You conclude practically. Okay. So these are the steps involved in one conducting hypothesis under Mann-Whitney U test. So do you have a question before we move on to solve?
No, please.
Okay. So let's move on to this particular one. So read the first question. Can you see the question?
Yes, I can see. Okay, so a random sample of starting monthly salaries for graduates from 2 Ghanaian universities are below 1,000 Ghana cedis.
Right. So these amounts are in thousands. All right. So move on to the question.
Is there enough evidence at the 5% significance level to say that the median starting salary for Eugene graduates is higher than the median starting salary for KNUST graduates?
So just list down the values for Eugene and the KNUST, but I'm going to switch back to the whiteboard for us to solve.
Okay. Can you remove the mouse pointer? I can't see whether it's 2 or 3. Okay. Okay, it's okay now. I'm done.
Okay, so they are acting as now. Look. Okay, let me copy the question. So what is the word here that corresponds to particular sign? Certain word here. So first of all, we are going to formulate what our null and alternative hypothesis, right?
Yeah.
Okay, so I'm trying to ask which word corresponds to a particular sign.
So here they are saying, is there enough evidence? Okay, the median was not, is higher than, so they want to know if the UG graduate is higher than the median starting salary for KNUST.
Okay, so the keyword is higher than, right?
Yeah, higher than.
And what's the sign for higher than?
Greater than.
Greater than. So the greater than is in which hypothesis?
Alternate.
Okay. So HO. We are seeing the median starting salary for Eugene. So Eugene, the median for Eugene will be M1. Do you get it?
Yeah.
Is higher than what? That's greater than a median starting salary for KNUST graduates, and that one will be what? M2.
M2.
So the opposite will be, if this one is greater than, then this one will be what?
Less than or equal to.
Less than or equal to M2. Okay.
Yeah.
So this is the what? Or you can write it this way. HO is like that. Okay, so this is M2, then this is less than or greater than. The 2 is here. Okay, so we can write it in this way or in this way, but I prefer you use this one because this one is the easiest way. Because this one, you don't take care, you confuse yourself. So just use this, the first one here.
Okay.
So we move on to the second step, which says we should calculate the U calculated or U statistic. And I'm saying that's where the workload lies. Are you getting it?
Yeah.
Okay. So let's move on to it's all right. I lost my network, and I hope you have the null and alternative hypothesis. So I'll move on to the second stage, which is saying that calculate our U statistic or U calculated. Okay. So this is where I said the workload lies. So this one I wrote something. I said you arrange the data values in the two populations in ascending order. That is from lowest to highest, irrespective of the group they belong, and rank them. After that, you sum up the ranks and use it to calculate the U for each group. Okay, so mention the data values for Eugene.
Okay, so 30.
Okay, 30.
35.
35.
29.
29.
37.5.
37.5. Okay.
32. 40.
That's all right.
Yeah.
Okay, let's move to KNUST.
28.5. 30.
Okay. Let's go.
30.5.
Okay.
26. 37. 29. 33. And 32. That's all.
Okay. So this is what I was saying. So you list them in ascending order. So the first one will be Eugene. You have R1, R2. Okay, so we are going to use these things here to rank them. We start with the ascending order. So from lowest to highest. So you mentioned the lowest values in either Eugene or KUST. We are using both populations. So you use the least one. So when you tell me the least number, you tell me the group or the population is coming from, whether it's coming from KUST or Eugene. And look at how I'm going to position them. You get it? So just start with the least value for me, ascending order. So lowest to highest.
Okay, so 26.
26. KNUST. Okay, so 26 will be here. Next.
28.5 KNUST.
Okay.
29. 29 KNUST. And UG2 has 29.
Okay, so when you look at this, you be like, oh, if the 29 is the first value for Eugene in terms of in terms of ranking or something like that, then I'll start 29 here. No, we don't do that. Just send the 29 to where the 29 for KUST is, so that they will be in line. You get it?
Okay.
Let's move on.
30 for both.
30 for both. So that one, they are in line. Okay.
Yeah.
Next.
30.5 for KNUST.
30.5 for KUST.
32 for both.
32 for both. Okay.
33 for KNUST.
33 for KUST.
35 for Eugene.
35 for Eugene, right?
Yeah.
Okay, so 35 for
Eugene.
Okay, so 35 should be on the next line. Do you get it? Because it's higher than the 33 here. Okay, look at how I am arranging them. Next.
37 for KNUST.
So that will be next line, then KNUST.
37.5 for Eugene.
So next line for Eugene, 37.5. Okay.
And 40 for Eugene.
40 for Eugene. You see how I did it?
Yeah.
So if two numbers will be on the line, then they should be the same.
Okay.
Good. Okay, so let's move on to ranking. How do you rank? So the lowest number will be 1, the next one will be 2 in that way. But when we get to the tie, the numbers which are tying, the workers are tying, they are sharing the positions. You know how to do them, okay?
Okay.
All right, so the first number will be 1. The position will be 1 first. You get it?
Yeah.
28.5 will be what? Sorry. The rank is for, look at their groups. The 26 was under KUST, so it will be rank 2. Okay, so here. Second is for what? KUST, right? Yes. But when you look at this, it will be 1, first, second, third, and fourth, right?
Yeah.
But this one, they are tying. It's a tie. 29 for Eugene, 29 for KUST. So what are you going to do? You add their respective positions, and divide by the numbers that are tying, or in other words, you divide by the number of appearance or the number of occurrence of that particular number tying. Do you get me?
Yeah.
Okay, so this one, it's the third and fourth position. That's where we are getting our tie from. Because if you are listing, it should be first, second, then third or fourth, or third or fourth. It shouldn't be third. Do you get it?
Yeah.
So we are going to calculate a certain value for these 229. So that's what we are going to use for our ranks. So as I said, the position is what? Third and fourth. So you add, and how many 29s are in here? 2. So if there were 4 29s, you divide by 4.
Yeah.
Okay, so give me the answer.
3.5.
So 3.5, you share the 3.5 for the 2. You get it?
Okay.
The 29 2 could be here. Eugene, 29. The next line will be 29. You use the same thing, third and fourth. You divide by 2. 3.5 here, 3.5 here. You get it? The 3.5 here, 3.5 here. if it was under Eugene or under Bob. It's the same method.
Okay.
So what do you think the next position will be?
I think fifth and sixth.
Fifth and sixth, good. Don't say that because we just calculated the ranks for third and fourth. We are going to use position 4 for the next one. No. Remember, we used the position third and fourth to calculate the 3.5, 3.5. So you have to move on. You move on the last position in mind. Do you get it? So the next one will be fifth. And looking at the fifth and sixth, they are also at time. Do you get it?
Yeah.
So that one too will be what? 5 plus 6 divided by how many 30s are in there?
2.
2. That will be
5.5.
good. 5.5. 5.5. And what do you think the next position, that's the 30.5, will be?
7th position.
7th position, yes, because we use the fifth and sixth to calculate the 5.5. So we move on. Now, 7th is here. We are moving to where? The 8th and 9th, right?
Yeah.
We are also tying. So it will be 8 plus 9 divided by 2. And that should give us
8.5.
So we share for them. Okay, so 33 will be what?
10th position.
10. Yes. Then the 35 will be
11th.
11. 37 will be
12th.
37.5 will be
13th.
40 will be
14th.
Now, take note here. Your last rank or position must be equal or should be equal. Now, your last rank. So which number is the last rank here?
14.
14. It should be equal to the number of sample sizes for the two populations combined. So when you combine the sample size for Eugene and sample size for Kenya, what do you get? So we have 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 2, 3, 4, 5, 6. 8 plus 6 will give us what?
14.
14. And you see that our last rank is what? 14. If you don't get that, then there's something wrong. You have to go back and check. Do you get what I'm trying to say?
Yeah.
And after that, you have to count the number size for Eugene, and you count them here if they are okay. So the Eugene was 6. 1, 2, 3, 4, 5, 6. Okay. Kenya is 8. 1, 2, 3, 4, 6, 7, 8. Correct. Okay. So we now sum up R1 and R2. Do that one for me.
Okay. So 55.5.
For
R1.
and R2 will be
49.5.
49.5. Okay. Let's move on. We are not done. So I told you this is where the workload lies. Okay. Now we have two check rules. So the first check rule. So the check rule 1. So the check rule 1. That one we used to check. We are checking to see if the R that we calculated, the two R's we calculated are correct, or if we are on track. You get it? Okay, so this is the formula. So R1 plus R2 should be equal to this n plus 1 divided by 2. Okay, so first R1 is what? 55.5, R2 is what? 49.5. Right?
Yeah.
You are saying it should be equal to the now n here is the sample size for two populations combined, so it was 14. So 55.5 plus 49.5 gives us
105.
105, and the one on the left hand side also gives us
105.
Okay, so we are on track. You have to check. Use this rule, this function or formula here to check to see if you are on track. If not, go back to rectify your mistakes. Other than that, you are doing cos 90. Okay, good. So we will have another check rule there. That's after we solved our U. Now we can move on to solve the U1 and U2. So U1 here, I quite remember I gave you the formula. So it was R1 minus N1 minus N1 plus 1 divided by what? 2. So just compute the U1 for me. So it will be 55.5 minus N1 is 6. This bracket 6 plus 1. What will be the answer?
The answer is 34.5.
34.5. Good. Now let's move on to solve the U2. That one to the N1 was it should be N2, not N1. So 8. Yeah. 8 plus 1 divided by.
You didn't write the R2.
You said
you wrote R2 should be 49.5.
Okay. Okay, we know this. So let me just use this thing. So R1 was 49.5 minus N2 is the population size for KMST is 8.
8, yeah.
I get 8 plus 1 divided by 2. That also gives
13.5.
13.5. And I said you choose one U to be your U calculated. And which criteria are you going to use to select your U?
You choose the minimum one. So
the minimum one, right?
Yeah.
Yes. Therefore, U calculated or U statistics or U calculated is 13.5. That's the minimum one. Choose the minimum one. When you compare U1 and U2, it can be U. The minimum one can be U2 or U1. Okay.
Yeah.
Let me write it here, or minimum. Okay. Now, before you move on to the step 3 in calculating your critical value, check to see whether your U1 and U2 you calculated are correct. You get it? So that's a check rule 2. You have to do these checks. So, answer Aboka.
Okay.
Okay, so that one to the formula is this: R1 plus R2 should be equal to N1 times N2. So you do that for me and let me see something.
Okay.
So R1 is 55.5 plus 49.5.
Give us 100.
Hold on. You will not add the R1, sorry. You add the U1 and U2, okay?
Okay.
All right. So U1 is what? 34.5 plus 13.5. It should give you your N1 times, so 8 times 6. So this one is giving you what?
48.
So we are on track.
Yes.
8 times 6 is also 40. So we are on track. Now, it's very, very important to check. Because if you don't check, your decision, everything will be wrong. And your decision or your conclusion carries the higher mark. Do you get it? Let me collect this since we don't notice. So the next one, we are moving on to what? U-crit. So I said the U-critical, you are going to combine the alpha and N1 and what? N2 to solve for your U-critical. So this one, we use a table called U-table. So let me show you that table. Can you see it?
Yes.
So with this one, we have two-tailed testing. And you also have what? One-tailed testing. So always know use your null and alternative hypothesis to identify whether you are dealing with one tail or two tails. So which one are you dealing with?
You are dealing with 1, 2.
One tail, because it was less than, the null was less than or equal to, and the alternate was what? Greater than. Okay.
Greater than.
So the alpha is 0.5. If it's not given, default is 0.5. So we have 0.5, 0.5 here. And the N1 was what? 6. You get it? N2 was what? 8.
N2 was 8.
Okay. So this is how we use it. 6 is here for N1. The top here is N1. You get it? And this side is N2. Top here is N1. Okay, so the 6 is here, N1. You trace it down to meet 8. Where is 8? 8 is here, right? 8 is here. Now, in the 8, we have 0.5 and 0.1. That's the level of significance. But mostly, they will be given to you in 0.05. So it will be 8, 0.5. Then you match it with what? The N1, which gives you
10.
Do you understand?
Yeah, I understand.
So N1, you place it down to meet the N2, then you choose your alpha, wherever they meet. So the U critical is 10.
Okay.
I want my friends in the dead and no one know how much I had for my.
Okay. So this was the third step. And let me move on to 4, where we decide. You get it? So with this one, you calculated is 13.5. And the U critical, okay? The U critical too is what? 10. So we always take it from the perspective of U calculated. So here U calculated is what?
Greater
Than critical. So what will be your decision?
So you fail to reject HO.
Decision. So we fail to reject HO. Hence U calculated 13.5. It's actually greater than what? U crit of 10 at 5% level of significance. And the question was like, conclude practically. Is there any enough evidence? The question is there enough evidence at the 5% level, significance level, to say that the median starting salary for UG graduates is higher than? And we said the higher than is in what? The null hypothesis, right? Greater than is in null hypothesis, alternate.
Alternate, yeah.
Yes. And we are saying we should reject HO. Meaning we are trying to accept. We are trying to accept. Yes, we are failing to reject HO, right? So we are failing to reject HO, meaning we are accepting the H O. Do you get it? Then HO is actually true. So if the HA was saying that Eugene graduate is higher than the starting salary for Eugene graduate is higher than median starting salary for Kenya University graduate, that was the what? HA. Then our answer is sending us, or is pointing us to what? HO. Then it means what?
So it means UG median starting salary for UG graduate is less than or equal to the median starting salary for KNUST graduates.
Yeah, so we can also use this. Is there any enough evidence? So this one, there is no enough evidence. You get it? So your conclusion would be there is not enough evidence that the median starting salaries of Eugene is higher than what? That of KNUST.
Yes.
Okay, so we are done. Do you have any questions?
No, well understood.
Okay, so let's solve the question 4 and close for the day.
Okay.
Okay, I'm waiting.
Okay, so should I read?
Yes.
Okay, so police records show the following number of crime reports for a sample of days during the winter months and a sample of days during the summer months. Use 5% level of significance to determine whether there is a significant difference between the winter and summer months in terms of the number of crime reports. What is your conclusion?
So write down the winter values and the summer values.
Okay. I'm done.
Okay. So winter. Okay, let's go.
So 18.
Winter.
Yeah, winter.
Okay.
20.
Okay.
15. 15, 15.
Okay.
16, 16. 21. 20. 12. 16. 19. And 20.
Summer.
Okay, so summer 20, 28. 18. 24. 32. 18. 29. 23. 38.
38.
Yeah. 28. 18.
Okay, so with this one, their sample size are equal, right? So
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2.
Yeah.
Okay. So as you already know, first step is formulate your what?
Null and alternative hypothesis.
Yes. So with this one, how do you think our null hypothesis will be and alternative hypothesis will be? So what is the word? What is the separate word here that corresponds to a certain sign?
So the word here is different.
So yes, is there whether there is a significant difference between? And I told you earlier this class that when you hear the word difference, they are talking about equal to, and equal to is two tildes. So the HO will be what? Equal to, and the HO will be what? Not equal. The HO will be equal to, HA will be what? Not equal to, right?
Yeah.
So the M1 is equal to what? M2. And with the HA, M1 is not equal to M2. Simple. Is different from. So the word different, the moment you hear different, bear in mind we are talking about what? The two tildes. Yes. Okay. So the first one is, and anytime you formulate your hypothesis, you have to understand. So the HO is trying to say that if something is equal, then there is no significant difference. You get it?
Yeah.
There's no significant difference. With the HA will be what? There is, right?
Yeah.
It's a significant difference. The second one will be what?
The second one.
No. I think I've made a mistake.
Oh, really?
So yes, so there is a significant difference with the HA, but with this one there is no. I don't really know. If something is equal, then it means there is no difference. Or
no difference. Yeah.
Yes. Good. So let's move on to the second part of the question. And that one is what? Calculate.
For your use statistic.
Okay. So let's use W for winter, S for summer, R1 here, R2 here. So like we did for the first one. So we are coming to rank them. We are going to arrange them in what ascending order. So the list, when you mention the list value, you mention where the population, whether it's W or X. Okay. So let's start. What's the list value here?
12 W.
Okay.
15 W. 16 W. 16 again in W.
16, there are 2 for W, right? Okay. So this is what you are going to do. You write it 2. You get it. And when you are ranking them, you use the same formula as we did in the other work. Okay. Let's move on.
18 for W. And for summer to 18. You have 3 18s in summer.
Okay, so this is how you are going to write it. So in all the 18s are 4, right?
Yeah.
So this you add their respective positions and add divide by 4 because the number of appearance or occurrence of 18 is 4. You get it?
Yeah.
So the next one is
19 W.
Okay.
20 W. So the 20s are 3 in W.
Okay.
Then 21 W. You have 23 in summer.
23 in summer.
Yeah. 24 also in summer.
Okay.
Double 28 in summer. You have 29 in summer. 32 in summer. And 38 in summer. That's all.
Thank you, Sine. Let me bring this one down. Okay. We are going to rank them.
Okay.
So what is the least value and where does it fall?
It falls in rank 1.
Rank 1. Okay, so the 12. So that will be 1. 15 will be 2. Now looking at 16, they are tying within the same population. And what's their respective position?
3rd and 4th.
3rd and 4th. So you add 3 plus 4, divide by how many 16s are appearing?
2.
So 3 plus 4 will be 7, divided by 2, 3.5. You share for them.
3.5. Okay.
Now with this one, we've moved on. So 1, 2, 3, 4. So the 18 here will be what?
5th.
5th position or the 5th rank, right? And the 18 here will be 6th The another 8 will be 7. The last 8 will be what? 8. So we are getting 5. We are getting 5 plus 6 plus 7 plus 8.
Plus 8.
We divide by how many 18s are appearing?
4.
4. The answer you get, you share it among them.
Okay. So you get 6.5.
So 6.5 for this one. And you move here 6.5. Share it for all of them. Now, what was the last position in mind?
8.
8. So the next one will be what?
9.
9. Okay. The next one, we are moving to 10th, 11th, and 12th. They are tying. So 10 plus 11 plus 12. Divide by how many 20s are appearing? 3.
3.
So 10 plus 11 plus 12 divided by 3 will give us
11.
11. So we share the 11 among them. That will be their ranks. Then, what was the last position in mind?
13. No, 12.
12. So the next one was 13.
13, yeah.
Oh, you didn't tell me this one. Okay. You have to send this particular one down. You understand? Because it shouldn't be on the same line with 21. You get it?
Yeah.
Okay. So 13. So 13 and
14.
That'll be the next line.
23, 14.
Yes.
For some.
And 15, right?
Yeah.
16 and 17 are tying. So 16 plus 17 divided by 2.
You get 16.5.
You get what?
16.5.
Share it among them. Okay. Then the next one will be, what was the last position in mind?
17.
17, so 18, 19, and what?
20.
Now, I taught you something here. I said the last rank must be equal to what? The sample size for the 2 populations. And the 2 populations, what to be the sample size for the winter and summer?
20.
20, right? 10 here, 10 here. The last one is what?
20.
So yes, you are correct. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And winter, you got everything. Summer, 1, 2, 3, 4, 5, 6, 8, 9, 10, 20. You got everything. Okay. Now, what will be the next step? You check whether the R, okay, we have to sum up the R1 and R2. So do that one for me. Sum up R1 and R2 for me.
Okay, I'm on it. So R1 is 71.5.
Okay, R1 is equal to 71.5. R2.
R2 is 138.5.
138.5. Okay, so we have to check. We have to check for R1. So check rule. So it will be R1. You already know the formula plus R2 is equal to the N. Here means the total sample size for all of them. So it will be 20 plus 1 divided by 2, the left right hand side.
So I had 210 for each side.
210 for both sides, right?
Yeah.
Okay. So this one will be 20. So here is 210. This one is also 210. Okay, so we are on track. We move on to solve for U1 and U2. You know the formula. So it's R1 minus N1 into bracket N1 plus 1 divided by 2. R1 is 71.5 minus N1 is 10 bracket 10 plus 1 all divided by 2. Okay,
So I had 16.5.
16.5.
Yeah.
This is the same formula to solve for U2. So U2 will be R1 was, oh, sorry. You see this line, the green line here? Oh, how do I change this? How do I change this? Does not affect all of them. You see, the 2 here does not affect the R1. That's what I'm trying to do. So this line is not passed. You get it? It's R1 on its own. You get it?
Yeah.
Yes, R1 on its own. Yes, so sorry that line crossed to the R1. Okay, so this one to be R2, which is 138.5. And this. So do that one for me and tell me the answer.
So I had 83.5. So it's 138.5 minus 10 into bracket 10 plus 1 all over divided by 2. And I got 83.5.
What's the figure?
83.5.
Okay. So what will be a U calculated? You choose a minimum one.
Yeah.
And that one will be 16.5.
16.5.
Okay. And you test for U. So check for 2. Test for U. And how do we test? It's U1 plus U2. Should give you your N1 times N2. 16.5 plus 83.5 will give you what?
100.
And this one to give you what?
10 times 10, 100.
So if you don't get the same, then sorry, you're not on the track. So what is the next step?
So right, you solve for T critical and U critical, sorry.
U critical, yes, you don't have T here. All right, so let us visit the table to solve. So that one is a combination of alpha, which is 0.5, comma N1, which is 10, comma, which is 10, N2. So it's alpha, comma, N1, comma, N2. Okay, so I lost my network, sorry. So U critical, I said it's a combination of what? The alpha, comma, N1, comma, what? N2. So the alpha is what? 0.5. N is 10. N1 is 10, N2 is 10. So let's go and add that. Can you see the table now?
Yeah.
Now with this, we're looking at the hypothesis we formulated. Is it one tail test or two tail test?
It's a two-tail test.
Yeah, so when you go to the first page of the file, you see two tail testing here. So you're going to look for 10 vertical, 10 horizontal, then match it with 0.5. So 10 is here. The 10 horizontal is here. 10 vertical is here. Wherever they are matching, you get it. You also use 0.5. Then you trace it. Where will they match? Here.
23.
So your critical value is what?
23.
23. Okay. So you crit is 23. So now you critical you calculated first. Always calculated before critical. You calculated it was at 16.5.
Yeah.
And the U crit is what?
23.
23. So you calculated is what? Less than U critical. And what was the rule? So looking at the rule or decision rule for Mann-Whitney or Wilcoxon Ranksum tests, what will be the decision?
So the decision will be we will reject HO since U calculated is less than U critical.
U calculated or U statistic. So you calculated is what? You calculated of
Less than
16.5. It's less than U critical of 23 at 5% significance level. Okay, so we are rejecting HO and looking at the hypothesis we formulated. What was the HO saying and what was HA also saying?
So the HO said there is a significance. There is no significance significance.
Yes, there is no significant difference.
There's no significant difference. Yeah.
And the HA is challenging that there is what? A significant difference.
Significant difference. Yeah.
And with this decision rule, we are saying we are rejecting HO. The HO is also saying there is no significant difference. And if we are rejecting HO, then what will be the conclusion? It means there is what?
Significant difference.
There is a significant difference. So conclusion will be there is enough evidence. Between winter and summer months. In terms of crime reports at 5% level of significance. So this is where the workload lies. I mean, calculating your statistic or U calculated. That's where the workload lies. You rearrange the data values in ascending order, irrespective of the group they belong to. After doing that, you rank them, you sum up the ranks, then you solve for your U1 and U2. You choose your U calculated. That's the minimum one in it, the least U in it. Then you move on to solve your U critical, then decision, you conclude. So the work lies in the stage 2 or step 2. Okay.
Okay.
So this brings us to the end of Mann-Whitney U test or Wilcoxon Ranksum test. And the next video, which will be session 6. Now it's left with 2 topics to complete the quantitative part of research methods. So I'm going to treat the ANOVA. After that, you treat correlation and regression. So the ANOVA, we have repeated something, independent something. And under correlation and regression too, you learn correlation, then you come and learn regression. So we've left with 2 topics, but you will meet, I think, 4 times, 2 for each topic, 2 meetings for each topic. Okay. Thank you for your time, and don't forget to share, like, and subscribe to our YouTube channel. Okay. So these are the questions. If you need it, you can test me. We have some questions. It was 5, and we just solved 2 of them, and they are not difficult. You just pinpoint out the keywords in it. So this one was saying if there is any difference. So the moment you see difference, is 2 tilted equal to and not equal to. You work for that one. With the question 3, at least is what? Greater than or what? Equal to. This one is greater than or equal to. It is what? Null hypothesis. The alternative be less than. You get it? Then you just look for the keywords. Look for the keywords. Just look for the keywords. This one too, if there is a significance or there is difference. Difference too is talking about equal to. So they are not difficult. They are not really difficult. They are not difficult. It's simple. It's very, very simple. Okay. So thank you for your time, and do well to study all of them. When you are studying, solve the historian set. Okay. Thank you for your time. Bye bye.